Hello. First and foremost, we are from Group 7. We will present about our project titled Industrial Effluent Treatment System IETS in Purijohan Ampurau Aquaculture, Sunjuan Berhad using Recirculating Aquaculture System, which is RAS. So in the next slide, we will show our video from site visit in Purijohan Aquaculture. So, my name is Lydia Lunisha. I will start presenting from chapter 1, which is Introduction. Our project location is in Purijohan Ampurau Aquaculture at Serian, Sarawak. And our mission is to sustainable fish farming using advanced wastewater treatment system. We conducted a site visit to Purijohan Ampurau Aquaculture, where the farm employs the industrial effluent treatment system utilizing the recirculating aquaculture system RAS to efficiently to manage wastewater. So what is wastewater treatment plant? It is a system that treats wastewater through screening, primary and secondary treatment, and final disinfection to meet environmental standard before being released. And what is recirculating aquaculture system? It is an eco-friendly fish farming method that recycle and treats water, reducing water usage and wastewater discharge, while maintaining optimal water quality for fish. So the party involved in this project is Purijohan Ampurau Aquaculture, which is the client and a project owner. Next is engineer and consultant, design and optimization of RAS, contractor, construction and installation of the system. Next is the regulatory bodies, the OE and Sarawak State Water Resource Department. Furthermore, local community, stakeholder with potential environment impact, and lastly is supplier, provision of equipment for wastewater treatment. For legal requirement in this project is Environmental Quality Act 1974. Next is Environmental Quality Industrial Effluent Regulation 2009, Department of Environment DOE, and Local Regulation Sarawak Water Resource Department. We will move to the chapter 2, which is statement of need. Okay, the first one is install recirculating aquaculture system RAS to minimize and recycle water. Second, implement industrial effluent treatment system IETS to treat wastewater and meet environmental discharge requirement. Third, comply with Malaysia Environmental Quality Act 1974 and Environmental Quality Industrial Effluent Regulation 2009 to avoid fines and ensure the legal operation. And we also need to protect nearby water bodies and promote biodiversity. And lastly, enhance the farm sustainability and environment reputation for long-term viability.
Hello everyone, my name is Muhammad Shaful Abidin bin Yahya and my metric number is 84759. And today I'm going to talk about our site evaluation and project option. For our site evaluation, we look at the current location of Puri Johan Ampurau Aquaculture, which is situated at Kampung Tai Serian, Sarawak. The site is ideal for aquaculture because it's just about 100 meters from the main road, which allows easy access for transportation of fish, equipment, and supplies. This accessibility is important not just for daily operation but also for expanding distribution to nearby market and restaurants. The total land area is about 2 hectares. Out of this, 0.8 is currently used for fish farming activities, including empurau, tilapia, koi, and masir. With about 18 tanks in operation, the remaining 1.2 hectares is used for other agricultural purposes, which gives the farm room to expand in the future. Another strength of this site is access to clean water sources and the existing infrastructure, including shelters for workers and owners, which support day-to-day operation. All these factors make the location suitable for implementing advanced systems like the RAS, which is a recirculating aquaculture system. And the proposed upgrade the site is not only functional, but also well positioned for long-term sustainability and environmental management. Okay, now I'm going to talk about the project option. The proposed upgrades to the RS, including the UV chamber and many more, as I mentioned here, bring several key benefits. Technically, they improve water quality by removing waste, reducing ammonia, and increase oxygen. And also can kill harmful bacteria, all essential for sensitive fish like Emporao. Economically, the system helps reduce losses, lower disease risk, and save labor through automation. It also helps avoid fines by meeting environmental regulations. Operationally, monitoring become easier and system is scalable for future growth. But on the downside, which is the disadvantages, the setup requires a high initial cost, regular maintenance, and technical training. It also relies on stable electricity, so a backup power plant is important. Despite the challenges, the upgrades are smart investment for long-term sustainability and efficiency.
Hello, my name is Andrew Isaac at 3062. I will proceed on chapter 4. For the Sampora farm, there are two phases of treatment. First one is the water intake treatment from the river to pond, and second is before the water is discharged, which the one that we focus on. Now I will discuss about the existing treatment at the Sampora farm. First is the mechanical filtration. It is equipped with a static mesh screen, and according to the person in charge, there is no drum filter used. The second process is the sludge removal, and it is only done only 2 to 4 times a year. And then the next one is biofilter. It is fixed using fixed media and added probiotics. Next is aeration. The aeration is only using air pumps and plastic tubing. And the next one is pH buffering. This farm is using oyster shells and coral chicks. And for the current design, there is no disinfection or final effluent monitoring. For the current design of the treatment, we observe a few problems, which one of them is inefficient solid removal. The next one is infrequent slush handling. Third is limited biological performance. And lastly, there is no pathogen control or sampling. Next one is 4.3 summary of improved system. So this is how the treatment looks like after we implement the improvement. First one is the primary treatment using drum filter for auto removal. Next is sludge trap using conical base. That is sludge removal. We improve it for monthly desludging. For the secondary treatment, we're using moving bed biofilm reactor. Next is fine bubble diffuser for aeration. And last is for secondary treatment is using probiotic or AM dosing to boost organic breakdown. And for the tertiary treatment, using sand carbon filter. Next is using UV disinfection unit. It is chemical free. And for the pH buffering chamber, using coral, oyster shell, and limestone to maintain the safe pH. And for the final control discharge and monitoring, we implement the sampling chamber for water quality testing. And then lastly, the process it is being discharged to land drainage area. That's it.
Hello, my name is Hesta Bongwenze, matrix number 86491, and today I will be discussing the existing environment for our proposed wastewater treatment plant. So the wastewater treatment plant we're proposing will be located right within the Puri Johan Aquaculture Farm in Serian, Sarawak. This section walks through the current environmental and infrastructure conditions of the site, just to help us understand the context we're working with. First of all, we will talk about the water quality, air quality, and biodiversity at the Puri Johan Aquaculture Farm, PGA. Aquaculture is a big part of Malaysia's food production, but it comes with environmental challenges, especially water use and wastewater discharge. PGA uses a recirculating aquaculture system, RAS, which helps reduce water use but still produces nutrient rich wastewater containing nitrogen, phosphorus, and organic matter. Initial water testing around the site shows elevated nutrient levels, which, if unmanaged, could cause eutrophication, basically algae overgrowth and low oxygen levels downstream. This is why proper treatment before discharge is critical. Next is air quality. PGA is in a remote rural area, so the air quality is generally good. Since RAS is a closed loop system, it doesn't release a lot of gases or pollutants, which is great. It even emits less ammonia compared to traditional pond system. The only trade-off is that RAS uses more electricity, but that can be offset by optimizing energy use or integrating renewables. Lastly, biodiversity. The farm is near small streams and vegetated areas, which support moderate local biodiversity. The good news is PGA wastewater undergoes some treatment via biofilters in the RAS. So when it is discharged, it is not raw sewage. It's already partially treated. If managed properly, treated aquaculture effluent can actually support biodiversity instead of harming it. Moving on to the existing infrastructure, PGA has reliable utilities such as electricity, a backup generator, and clean water. This is important because RAS systems are energy intensive. In fact, they can use up to 15 to 30 kilowatt hour per kg of fish produced. So having a stable power source is essential, especially with plans to operate a wastewater treatment plant. As for transportation, the access is solid. The farm is just under 17 kilometers from Serian town, less than a 20-minute drive that's useful for transporting materials, equipment, or chemicals during water treatment plant construction and operations. Next is the waste management. Here is where it gets interesting. PGA uses manual sludge lifting and basic waste recirculation inside the RAS. The biofilter reduces some nutrients, but residual wastewater still needs to be discharged, and right now that goes through into the drainage system or sometimes onto land as runoff. While it's not raw wastewater, it can still carry high concentration of nitrate, phosphate, and organic solids, especially if the system is overloaded or poorly maintained. The sludge from filters is removed, but it's not stabilized or reused, so we're missing out on potential nutrient recovery. Lastly, we will discuss the environmental interaction and impact. Now, building the wastewater treatment plant comes with some short term risks, like noise, dust, and machinery emissions during construction. But these are temporary and can be easily managed with proper safety and environmental measures. The most important issue here is making sure the water we discharge meets environmental standards. If it's not properly treated, it could harm ecosystems downstream. A properly designed wastewater treatment plant will drastically cut nutrient pollution. We can even explore more advanced biological or microalgal treatments to polish the water before discharge. That supports sustainability, helps prevent algal blooms, and protect both the environment and community health. That's all from me. Thank you.
Next, for chapter 6 is evaluation of impact. So this is the pre-treatment sample data from past study, and this will explain more in our report. And here is the citation for our sample data. Evaluation of impacts, the first one is the water quality impact. The issue is ammonia, nitrogen compounds, suspended solid, and organic pollutants in wastewater. The impact is harmful to aquatic life. Suspended solid reduce water clarity and oxygen. Second, air quality impact. The issue is release of ammonia, methane, and hydrogen sulfide gases during wastewater treatment. The impact is potential health risk to workers and residents. Air pollution. Third is soil and land use impact. Issue is wastewater runoff and sludge disposal affecting soil quality. The impact is to soil contamination and erosion. Fourth is impact on local communities. The issue is water contamination, odors, and noise pollution. The impact is health risk and reduced quality of life for nearby residents.
What's up, guys? For Chapter 7, our focus is on mitigation measures taken to minimize the environmental and operational risks associated with the wastewater treatment plant at Puri Johan Empurau Aquaculture. This includes actions planned during both the construction and operational phases of the recirculating aquaculture system, or RAS. There are several key risks we identified during our assessment. These include the buildup of ammonia and nitrate, which is toxic to fish and harmful to the environment, and sludge accumulation that could clog system components. We also considered noise pollution from pumps and blowers, power outages that can halt water circulation, chemical spills, and unsafe discharge of treated water into land and nearby drainage, which could cause environmental damage. So next is the key mitigation actions. So to address this, multiple mitigation strategies were proposed. We recommended real-time water quality sensors to monitor ammonia, nitrate, and oxygen levels, supported by weekly manual testing and optimized feeding. For sludge, we propose regular desludging using on-site drying beds. To minimize the noise, low decibel pumps and daytime only operations are to be suggested. We also included diesel generators for backup power, bonded chemical storage, and staff safety training. Lastly, to manage water discharge to land, vegetative filter strips and sediment traps are planned for. So lastly is the compliance and monitoring. All these actions aim to comply EQA 1974, DOE, and NREB Sarawak regulations. The project will conduct monthly effluent testing for parameters like BOD, COD, and ammonia, or TSS included, and track these results using a compliance dashboard. If any issues occurs, a corrective action plan, or CAP, will be activated within 24 hours. With this, the project ensures safe, sustainable aquaculture operations with minimal environmental impact.
So for the conclusion, the RAS system recycles water but produces wastewater with pollutant. Proper treatment and environmental management plan can minimize environmental impact, ensuring compliance and sustainability for Puri Johan and Purau. So our recommendation is to enhance the mechanical filtration. Next is to implement biofilter and conduct regular air quality monitoring. For soil management, use erosion control measure and post-construction land rehab. And then regularly check effluent quality to protect water supply, and install soundproofing and odor management system. Lastly is to continuously monitor and audit RAS to ensure compliance. Thank you.